Welcome to The Explainer, where we are going to dive into the terrifying and honestly, absolutely fascinating cosmic mystery of why a universe filled with a billion trillion stars appears completely dead. I mean, when we look up at the night sky, we see this infinite expanse of potential. Yet, as far as we can currently observe, we are completely alone. Today we're going to explore a concept that attempts to explain this eerie silence. It's a hypothesis that forces us to look at our own history and our future with some really intense scrutiny.
So, where is everybody? That simple question is the core of the famous Fermi Paradox. We live in a universe with countless star systems, right? And many of those contain planets that could potentially harbor life. Because life naturally expands and fills all available niches, it really stands to reason that highly advanced civilizations should have eventually developed technologies, like self-replicating spacecraft, to spread across neighboring star systems or even across entire galaxies. Yet there is absolutely no reliable evidence that aliens have ever visited Earth. We haven't observed any intelligent extraterrestrial life with our current technology, and our searches for extraterrestrial intelligence haven't picked up a single transmission. Nothing.
Section 3. The Silent Universe.
Despite decades of scanning the heavens, the cosmos appears utterly quiet. And to really grasp the gravity of this absence, we have to look closely at our astronomical observations. The universe, apart from our own tiny blue planet, seems entirely lifeless. This brings us to a pretty chilling observation made by researcher Robin Hansen. He noted that our planet and solar system do not look substantially colonized by advanced, competitive life from the stars. And honestly, neither does anything else we see in the galaxy. He wrote, "We have had great success at explaining the behavior of our planet and solar system via simple, dead physical processes rather than the complex, purposeful processes of advanced life. Basically, if an advanced civilization had colonized our neighborhood, we'd definitely know it by now. Instead, we just see dead matter reacting to basic physics."
Okay, let's dive into the core concept that was actually proposed to resolve this very paradox. It's known as the Great Filter. First formulated by Hansen in a 1996 essay, the Great Filter is this idea that between the earliest stages of life forming from non-living matter and a civilization reaching the highest levels of technological development, there exists a massive barrier. This barrier is what makes detectable extraterrestrial life exceedingly rare. The main, sobering takeaway here is that there's an inverse correlation at play. The more probable it is that other life could evolve to the present stage that humanity is currently in, the bleaker humanity's chances of surviving into the future probably are.
Section 4. 9 Steps to Colonization.
To figure out where this theoretical barrier might be, we really have to look at the incredibly difficult evolutionary path required to reach an explosive state of interstellar colonization. Starting with a basic star and ending with an advanced, expanding civilization is clearly an unlikely process. That means at least one step along the way must be highly improbable. Hansen outlined 9 critical steps for this. It starts with having the right star system and the formation of reproductive molecules like RNA. Then, life has to evolve from simple, single-celled prokaryotes into complex eukaryotes, develop sexual reproduction, and become multicellular. From there, you need the rise of tool-using animals with intelligence, the building of a civilization advancing towards space travel, and finally, step 9, an explosion of interstellar colonization. Because we don't see a Milky Way just packed full of alien colonies, the Great Filter hypothesis dictates that at least one of these exact steps must be incredibly improbable.
Section 5. Is the filter ahead?
And this brings us to the most terrifying implication of this entire theory. We know steps 1 through 8 have actually occurred here on Earth, but where exactly is the barrier? If the highly improbable step is an early one that we've already passed, well, it means humanity is exceedingly rare, and we survived a bottleneck that almost no one else in the universe does. However, if those past evolutionary steps are actually quite likely, then a ton of civilization should have reached our current level. Since we don't see them at step 9, that implies the Great Filter lies squarely in our future. It means the only things keeping humanity from interstellar colonization are looming catastrophes, resource exhaustion, or self-destruction. In this scenario, our survival prospects are pretty bleak.
Because of this logic, we arrive at a highly counterintuitive idea. You'd think finding life on Mars would be amazing, right? But actually, finding multicellular life on Mars would be terrible news for humanity. If we were to discover independent, evolving life on another planet right in our own solar system, it would imply that steps 2 through 6 on our list are actually quite easy and common. And if the early steps are easy, it practically guarantees that the big, improbable barrier, the Great Filter, hasn't been passed yet. It's still waiting for us.
But hey, there is some hope that the filter is firmly behind us.
astrophysicist Matt O'Dowd has identified Step 4, eukaryogenesis, which is the leap to complex single-cell life, as a very reasonable candidate for a great filter in our past. This is because of the extreme evolutionary difficulties in finding new, useful proteins for simple prokaryotic cells to actually make that leap. If this transition is as mathematically improbable as some evolutionary biology suggests, we might have already cleared the hardest hurdle.
Section 6. Future Threats and Filters.
Now, if we haven't passed the filter, what could possibly act as a barrier between our current civilization and an interstellar colonization explosion? Researchers have suggested a few specific potential future filters. First, we have severe resource exhaustion, basically consuming available energy resources before the civilization can make the leap to the stars. Second, paleobiologist Olive Vinn recently suggested the filter exists due to inherited behavior patterns. These are biological drives that initially occur in all intelligent organisms but are ultimately incompatible with the conditions of a high-tech civilization, inevitably leading to self-destruction. And third, there is the deeply chilling berserker hypothesis. This proposes a filter where any emerging civilization is actively destroyed by lethal, self-replicating von Neumann probes, created by an older, more advanced civilization that just wants to eliminate the competition.
Section 7. Looking for signatures.
So, how can we figure out which scenario is actually true? Well, our current astronomy and future telescopes might hold the key to solving the Great Filter mystery by scanning the galaxy for specific types of evidence. A 2020 paper by Jacob Hock-Misra and colleagues argues that future telescopes could look for both biosignatures, which are signs of biological life, and technosignatures, signs of technology. If we find that planets with technosignatures are abundant, it increases our confidence that the Great Filter is in the past and we are safe. But if we find that basic biological life is incredibly commonplace throughout the galaxy, but technosignatures are completely absent, that dramatically increases the likelihood that the Great Filter lies squarely in our future.
Section 8. Alternative Theories and Futures.
Of course, we should note the Great Filter isn't the absolute only explanation for a quiet universe. Some scientists suggest non-catastrophic reasons for the silence of the stars, arguing that intelligent life might evolve multiple times without destroying itself, yet still leave no glaringly visible evidence. Astronomer Seth Shostak from the SETI Institute presents a fascinating alternative. He points out that the Fermi Paradox assumes highly visible megascale construction projects, like Dyson spheres rearranging whole star systems, are just an inevitable outcome of intelligence. But what if they aren't? Shostak proposes the theory of the inevitability of small engineering, where advanced life simply chooses a completely different path.
Shostak notes that the laws of physics heavily favor the small. The laws of inertia mean that smaller machines are faster and require much less energy to function. Furthermore, the absolute speed limit of the universe, the speed of light, means that small computers have much faster internal communication. So, because of all this, advanced societies might have very little incentive to rearrange the stars. Instead, they might prefer to build incredibly small, ultra-efficient nanobots. Their technology would be microscopic, not macroscopic.
Which leaves us with this profound thought from Arthur C. Clarke to conclude our explainer. Truly advanced engineering would look like magic to us, or be unrecognizable altogether. Perhaps the universe isn't a graveyard of civilizations that failed to pass the Great Filter. Perhaps they have successfully navigated the evolutionary barriers, but their technology is simply invisible magic to our eyes. So the next time you look up at the night sky, ask yourself, are we uniquely lucky to be alive? Is our greatest test still waiting ahead of us, or is the universe already watching us, just too small to see?